Good morning, everyone. This is Miss Moore here. Today we are going to be talking about angles, and all we're doing here is we are going to activate some knowledge that you already know. So let's talk about what an angle is. An angle is formed by two rays with a common endpoint. And over here we see this with the rays identified in yellow. Now the common endpoint I just talked about is called the vertex. It's where they come together. And I'll show you over here on the diagram where the vertex is. Now, when we talk about the rays, we're talking about the sides of the angle. All right? When we go to start naming angles, we are going to use 3 letters, and we are going to make sure that the middle letter is going to be the vertex. Okay? And we will use a single letter if there's only one angle located at the vertex. But when we're talking about the measurement of an angle, we're going to use a lowercase m, and that's shown right here. All right, now let's talk about the different types of angles. So first we have an acute angle. Acute angles are the angles that are less than 90 degrees. So when you think of acute, think of all, just cute. They're small. Then we have obtuse. Obtuse angles are the ones that are greater than 90 degrees. Then finally, we have this symbol right here. It is so important that you know what this symbol is. This symbol represents a right angle, and we know that right angles are equal to 90 degrees. Then we have our straight angle. Straight angles are just a straight line, and they equal 180 degrees. All right, let's take a look at some examples here. So first, let's name the vertex. Well, the vertex is just a point, it's K. Let's look at the sides. I know that sides are made up of rays, so I'm going to start with my vertex and name the endpoint. It's ray KJ and ray KL. Now I'm going to name the angle in 3 ways. I know I can name it with just the vertex, but I can also name it using the other endpoints, just making sure that vertex is in the middle. And then I'll classify the angle. Well, I'm looking to compare it to the right angle, and I see it's greater than the right angle, so it is obtuse. All right, let's see another example here. I'm going to name the vertex. It's just a point, it's S. Let's name the sides. I'm going to start with my vertex, vertex SR, and vertex ST. Then I'm going to name the angle. I will start with my vertex, so angle S. Then I will include my other endpoints, putting angle S in the middle, just to show that that is my vertex. Now when I classify, there is an important symbol over here. That is a right angle. Right on. Now let's talk about congruent angles really quick. If the measurement of angle A equals the measurement of angle B, which we see over here, they both are 75 degrees, then the two angles are congruent. They are the same. So we write this as angle A is congruent to angle B. All right, so now let's talk about an angle bisector. So whenever we see the word bisector, we're talking about things that cut in half, okay? They bisect. So when we're talking about angles, we're talking about a ray that divides an angle into 2 congruent angles. So let's take a look at the diagram on the right. I know that ray BD is an angle bisector. Therefore, I know that angle ABD is congruent to angle DBC. So that ray creates 2 angles that are the same and we see this by this mark right here. They're congruent. Now, perpendicular lines are two lines that intersect at a right angle. And again, this is prior knowledge that we already know, and we see this with this symbol again. Now, the symbol for a perpendicular bisector is this right here, an upside down T. So in the diagram to the right, we say that line L, is perpendicular to line M. So what does that mean for perpendicular bisectors? We see that word again. So a line, a segment, or ray is perpendicular to a segment at its midpoint. Okay, so in the diagram to the right, we see that LM is the perpendicular bisector to PQ. So once again, LM is perpendicular to PQ, and we see that with the right angle symbol. Okay, so what this tells us, the perpendicular bisector, is that LM split PQ in half at its midpoint. All right, so let's go ahead and work through example 3 independently.